Step 1, replace f of x by y. Step 2, interchange x and y. So my y's become x's, and my x's become y's. Now that's thrown me to the range. And then step 3, solve for y. Now remember, this is a rational equation. So the first thing I have to do is clear the denominator. You can either cross multiply, and some of you might be used to doing that, or multiplying both sides by the LCD, which is y minus 1. So you get that x times y minus 1 equals negative 2y, because the y minus 1's cancel. Now I got to solve for y, which means I got to give y alone. And I've got y in two places. I have a y here and a y inside the parentheses. So I've got to clear the parentheses to get the y out. So xy minus x equals negative 2y. Now I can do one of two things. I can bring the y's together on the left, on the right. I'm not so thrilled about doing that, primarily because I'd have a negative 2y and a negative xy. So I think I'm going to take the x over. So I get that xy equals negative 2y plus x. And then I'm going to bring the 2y over. So that xy plus 2y equals x. Now I've got everything with a y in it on one side and everything with x's that doesn't have a y in it on the other. And we look at the trick. And the trick is to factor out a y on the left-hand side, so that y times x plus 2 equals x. Divide both sides by x plus 2. So that y equals x over x plus 2. That's really what F inverse is. Now to verify, and I'm going to need a little bit more space, I need to pick somebody, doesn't matter who I pick, that f inverse of x equals x. Or that in the function f, wherever there is an x, I'm going to put the inverse. So I have minus 2x over x minus 1. And the inverse is x over x plus 2. That's how we get complex fractions. So I'll have negative 2x over x plus 2. And then here I need a common denominator, x plus 2 over x plus 2. So over x plus 2, I'm going to have x minus 1 times x plus 2, which is minus 2x over x plus 2. Then I'll have an x minus x minus 2 over x plus 2. Which is minus 2x over x plus 2. X's add the 0. I have minus 2 over x plus 2. And now what do I need to do? I have a single fraction divided by a single fraction, and what do I do? Divide. Invert and multiply. Negative 2x over x plus 2 times x plus 2 over negative 2. X plus 2's divide out. Negative 2's divide out. And this is indeed equal to x. And it verifies. It is. It is. Now, just off the top, since this is what you guys are still copying, what's the domain of the inverse function? If this is the inverse function, what's this domain? All real numbers, x can't be negative 2, right? Don't know what the range is, haven't a clue. What's the domain of the original function? And remember what the original function was way back when, someday in the great beyond. There's the original function. What's this domain? All real numbers, x can't be 1. Now I could draw a picture, but what I realize is this, is that I go from the domain, and this would be, the domain of the inverse is the range of the original function. So if I'm going from x can't be 1 to x can't be negative 2, what's the range of the original function? Y can't be negative 2. Because this guy's the range of the original function. Now if I'm coming back, right, I'm coming back, I'm starting with all x is not equal to negative 2, I'm coming back to here, this says what? Y can't be 1. And normally what we do is realize it's a crisscross. You just change the x's to y's. That's it in a nutshell.